Let's take a look at this voltage divider. We're supposed to find VTH, RTH, and the following currents and voltages. Okay, so VTH is the voltage between the base and ground, making the long story short. So VTH is equal VCC times R2 over R1 plus R2. Okay, I'm going to use the voltage divider formula in order to find the voltage across resistor R2, because voltage across resistor R2 is simply the voltage at the base. Okay, so this is going to be my VTH. So VCC is equal 30 volts times R2, which is equal 3.9 kilo ohms, over, open parenthesis, I have 39 kilo ohms plus 3.9 kilo ohms. So this is equal VTH, I have 30, open parenthesis, 3.9 exponent 3 divided by, open parenthesis, 39 exponent 3 plus 3.9 exponent 3, close parenthesis equals 2.72 volts. So my VTH is 2.72 volts. Okay, so this is, other words, voltage at the base in this case. So next we're supposed to find RTH. RTH is simply the combination of these two resistors that are in parallel. So we have RTH is equal R1 times R2 over R1 plus R2. Someone is going to ask why they are in parallel, because when you are going to do analysis, you have to connect your VCC to the ground, and you are going to find out that this resistor R2 is in parallel with R1 if you connect this terminal to the ground. Okay, so that's why they're in parallel. So R1 is equal 39 kilo ohms times 3.9 kilo ohms over 39 kilo ohms plus 3.9 kilo ohms. This is equal 39 exponent 3 times 3.9 exponent 3 equals, divided by, open parenthesis, 39 exponent 3 plus 3.9 exponent 3, close parenthesis, equals 3.54 kilo ohms. Okay, so this is my RTH. Okay, let me just remind you one more time. Anytime you do Thevenin's theorem and you want to find the RTH or ZTH, you're supposed to connect the source to the ground. So if you connect the source to the ground, you will find out that these two resistors are in parallel. Next, we're supposed to find IB. The formula says IB is equal, I'm making the long story short, VTH minus VBE over RTH plus beta plus 1 times RE. Okay, so this is the formula which you're supposed to remember. And I have VTH equals 2.72 volts minus 0.7 volts divided by, open parenthesis, RTH 3.54 kilo ohms plus beta plus 1, so if 120 plus 1 is 121 times RE 1.8 kilo ohms. Okay, this is equal IB, and I have 2.72 minus 0.7 divided by open parenthesis 3.54 exponent 3 plus 121 times 1.8 exponent 3 close parenthesis. This is equal 9.12 microamps. So IB is equal 9.12 microamps. Okay, so this is my IB. Next, I'm supposed to find IC. IC is the current which goes through the resistor RC and goes through the collector. So I have formula IB times beta, where IB is equal 9.12 microamps times 120. This is my beta. So I have 9.12 exponent 6 negative times 120 equals 1.09 milliamps. 1.09 milliamps. So this is my IC. Next, I'm supposed to find IE. IE is equal IB plus IC, where IB is equal 9.12 microamps plus IC, which is equal 1.09 milliamps. This is equal 1.1 milliamps. Next, we're supposed to find VE. Okay, VE is the voltage between emitter and ground, or other words, voltage across resistor RE. So VE is equal to VRE. It's the same thing. Okay, if you are going to measure voltage from the emitter to ground, this is the same like measuring the voltage across resistor RE. So I can say this is equal IE times RE, where IE is equal 1.1 milliamps times RE 1.8 kiloohms. This is equal 1.1 exponent 3 negative times 1.8 exponent 3 is equal 1.98 volts. Okay, so this is the voltage VE. Next, I'm supposed to find voltage VB. As you remember, we said that VTH is the voltage at the base. That's why I'm going to say VB is equal VTH, and this is equal 2.72 volts. Okay, and next we're supposed to find VC. VC is equal VCC minus voltage across the resistor RC. Voltage across resistor RC you can find by multiplying IC times RC. That's why I'm going to say that this is VCC minus VRC, which is equal VCC minus IC times RC, because VRC is equal IC times RC, where VCC is equal 30 volts minus IC 1.09 milliamps times RC, which is equal 2.2 kiloohms. So VC is equal 30 minus 1.09 exponent 3 negative times 2.2 exponent 3. This is equal 27.6 volts. 27.6 volts. This is my VC. Next, I'm supposed to find VCE. VCE is the voltage between the collector and emitter. Okay, so VCE is equal VC minus VE, and VC is equal 27.6 volts minus VE 1.09 98 volts. This is equal 25.62 volts. Okay, so this is my VCE. Next, I'm supposed to find IC sat. IC saturation is equal VCC divided by resistor RC and resistor RE. This is the maximum current which will go from the collector to emitter. So this is RC plus RE. This is equal 30 volts divided by RC 2.2 kilo ohms plus RE, which is equal 1.8 kilo ohms. This is equal 30 divided by open parenthesis 2.2 exponent 3 plus 1.8 exponent 3 close parenthesis. This is equal 7.5 milliamps. This is 7.5 milliamps. Okay, so now we can say that the problem is solved.